One of the most classic movies of all time is Back to the Future. The original came out in 1985, and the sequels in 1989 and 1990 are fantastic. It is impossible to talk about those films without talking about the second one, when Marty and Doc travel to 2015 and meet hoverboards, those skateboards that float above the pavement. When the real year 2015 finally arrived, the internet spent a month pretending scientists were running out of time to deliver one. I dreamed about owning a hoverboard. You still see people online asking why it does not exist yet. Some teams even built machines that imitated the movie. Boards that hover on a cushion of air or on magnets over special tracks. None of them became the film version, the one that would float down any ordinary street without rails and without fans underneath. This video is not here to mock the dream. The dream is rational. Gravity is the tax every moving machine pays. Cancel the tax and transportation changes shape. Cities, war, sport, everything. The problem is that anti-gravity is one of the most abused words on the internet. People use it for magnets, for compressed air, for camera tricks. Before we ask whether anti-gravity is possible, we need to strip the word back to something physics can test. That is the thread holding this story together. Definition first, then experiments, then why the universe keeps saying no. That gap between the movie and our world raises a bigger question. If our technology has come so far, why do we still not have floating skateboards? Why not floating cars, trains, buses, or ships? Imagine a Formula 1 race where tires never fought friction against the track. Imagine transports that did not need roads to be tough enough to carry weight at speed. All of that fantasy depends on one idea: canceling gravity, or at least canceling enough of it that an object stops being pulled toward Earth's mass. That idea has a name: anti-gravity. The hoverboard chase in Back to the Future Part 2 is not random set dressing. It encodes a whole 20th century promise that progress means escaping weight. We got smartphones, the internet, and reusable rockets. But gravity stayed exactly the same as in 1985. That is why the meme hurt when 2015 arrived. The future showed up without the one toy everyone remembered. Inventors responded the way inventors always respond. Hindu Hover tried magnetic boards over copper surfaces. Lexus built a superconductor demo with liquid nitrogen smoke for ads. Teens used leaf blowers to lift plywood, wire, and awe. Each project taught real physics while failing the movie test. The movie board needed one thing: no track, no fans, no special floor, just nullified weight over ordinary asphalt. That requirement is what separates Hollywood from the good award. Doc Brown's DeLorean time machine already cheated physics with flux capacitors. Marty on a hoverboard cheated friction with a floating plank. Audiences accepted both because the films never pretended to teach a lab course. They sold joy. The trouble starts when joy leaks into expectations about real R&D timeline. Technology does advance quickly in computers and biotech. Fundamental forces change slowly because they are not product, they are the stage. You can build better lights on the stage. Anti-gravity would mean rewriting the stage itself for one prop. That is why serious physicists treat the word like an alarm bell, not a product category. But before we go any further, we need to agree on what the word means in this video, because half the confusion online comes from calling everything anti-gravity. Here we are talking about nullifying the effect of gravity, making an object behave as if Earth's pull were gone or reversed, not about balancing gravity with another force that happens to point upward. That distinction sounds picky until you realize it is the whole argument. A magnet lifting a metal ball is not anti-gravity. A maglev train is not anti-gravity. A hovercraft blowing air downward is not anti-gravity. A boat floating because it displaces water is not anti-gravity. In every one of those cases, gravity still wins the accounting. Earth still pull. You just introduced a second force strong enough to hold the object up. Anti-gravity, in the sense science fiction and prize committees use the word, would mean switching gravity off for that object, the way you might switch a light off, not shining a brighter lamp beside it. Let me make that concrete. Stand on a bathroom scale. Maglev you off the floor with magnets under the tile. The scale reads 0. Did you cancel gravity? No. Tigid had taper. The magnetic force pushed up on your feet with exactly the force gravity pulled down before the floor transmitted it. Remove the magnets, and you drop. Anti-gravity would mean the scale reads 0 while nothing pushes up. while Earth is still there, while your mass is still there. But the coupling between mass and gravitational field locally vanishes. No one has demonstrated that for 20 grams for 1 minute at 10 centimeters. That is not an arbitrary threshold. That is the Gold Award specification written by people who got tired of watching magnets on YouTube. Let me show you why that matters with the example everyone loves to film. Magnetic levitation. Maglev looks like magic in slow motion. A superconducting puck floats above a track. A train in Shanghai or Japan glides with no wheels touching rail. Your brain says flying. Physics says Lorentz force when a superconductor expels magnetic fields, or when electromagnets push on a moving train. You are watching electricity and magnetism fight downward pull. Gravity never left the room. It is still pulling on every atom in the train. The magnetic force just points up hard enough that the net motion is levitation. And here is the punchline that connects to the rest of the video. Gravity is allowed to lose that fight because it is absurdly weak compared with electromagnetism. Take the Shanghai Transrapid as a reality check. Those trains levitate on a guideway with powerful electromagnets and reach commercial speeds over 400 kilometers per hour. The engineering is stunning. The physics is still a tug of war. Cut power to the magnets and gravity collects its debt instantly. Nothing in the system reduced Earth's field over the Yangtze Delta. The train simply had a stronger vertical force budget. While powered, that is the template for almost every floating demo you will ever see. Impressive force balance, zero anti-gravity, major, free, and one major. First, free. Interesting. 1. Weakens. Japan's Smaglev program pushes the same logic toward even higher speeds with superconducting coils on the train and guideway coils that interact to lift and propel. Chuo Shinkansen test runs have exceeded 600 kilometers per hour. The nation is building infrastructure for a maglev era that still depends on electricity fighting gravity every second of every trip. If someone tells you superconductors prove anti-gravity because the train floats, ask them what happens when the power substation fails. Physics answers faster than marketing. Superconducting maglev adds another layer people confuse with gravity cancellation. Below a critical temperature, certain materials expel magnetic fields through the Messner effect. The field lines get pushed out of the bulk, and a magnet above the superconductor can lock in place with eerie stability. Videos of quantum levitation with liquid nitrogen look like wizards discovered a new law. They did not. They discovered that superconductivity plus magnetic flux pinning creates stable levitation within the field geometry you built. Tilt the track and the puck follows because the magnetic constraint curves with it. Still not anti-gravity. Wa and Tekrabed still paid for with electromagnetism and cryogenics. Among the 4 known fundamental forces, strong nuclear, weak nuclear, electromagnetic, and gravitational, gravity is the runt. Physicists often say it is roughly 10 to the 39th or 10 to the 40th times weaker than the electromagnetic force, depending on which particles you compare and how you normalize the bookkeeping. Put 2 protons a meter apart, and the electric repulsion between them crushes the gravitational attraction by something on the order of 10 to the 36th to 10 to the 40th. Earth has the mass of an entire planet and still cannot beat a fridge magnet plucking a paperclip off a table. That is not because Earth is lazy. It is because gravity's coupling constant is tiny. Why does gravity feel so strong in daily life if it is the weakest force? Because most large objects are electrically neutral. Positive and negative charges cancel to incredible precision, leaving almost no net electromagnetic pull on you from the planet. Gravity has no negative mass counterpart in ordinary matter that cancels out. Every proton and every electron adds pull in the same direction when you stack a planet. Electromagnetism is stronger unit for unit, but it mostly cancels itself in bulk matter. Gravity accumulates. That is why you notice Earth's pull every morning when you stand up, even though a single electron's electric field is monstrous compared with its gravitational field. Compare the strong nuclear force, and the picture gets even starker. The strong force holds quarks inside protons at energies where gravity might as well not exist. The weak force governs radioactive decay at short range. Gravity only dominates at large scales because it adds without canceling, and because it reaches across infinite range without saturating like the strong force. Anti-gravity fantasies often skip this hierarchy. They treat gravity like a knob on a mixing board. Physics treats it like the quietest instrument in the orchestra that somehow conducts galaxies because every other instrument is playing in pairs that cancel on stage. So when maglev works, You are not seeing gravity fail. You are seeing electromagnetism win an arm wrestling match against the weakest force in the universe. That is impressive engineering. It is not anti-gravity. The same logic applies to iron lifters and electrostatic tricks you see on video platforms. Fans and wings and balloons are even more honest about what they do. They shove air or water around. Nothing in those demos turns down the gravitational field of Earth. They just pay the energy bill to hold something up against it. Ion lifters, those triangular wire rigs that hiss and climb off a table, are a perfect teaching tool because they look like UFOs and behave like freshman physics. A high-voltage corona discharges ions from a thin wire toward a collector. The ion wind pushes the rig upward. Measure the thrust, and you find electromagnetism and air momentum doing the lifting. Weigh the rig on a scale, and gravity never stopped acting on every gram. Cut the power, and the lifter falls immediately. Comments still call it anti-gravity because floating is floating in human eyes. In equations, it is another force budget problem. Boats float for a related reason that also gets mislabeled. A ship displaces water until the upward buoyant force equals weight. Archimedes understood that 23 centuries ago. The ship is not canceling gravity. It is receiving a normal force from fluid pressure. Submarines rise and fall by changing average density, not by editing Earth's field. If anti-gravity existed as a technology, you would not need water, magnets, wings, or ion wind. You would need a switch. Nobody has shown the switch. Once you accept that definition, a lot of viral claims collapse on their own. Big fans under a platform. Engineering, not anti-gravity. Magnets, engineering. Gyroscopes spinning in a garage, also not anti-gravity. And we will come back to that because the gyroscope myth had its own little research career. The pattern on social media is predictable. Stage 1, film something floating. Stage 2, call it anti-gravity in the title. Stage 3, omit the power cable, the air hose, the hidden magnet, or the angled camera that hides the support. Stage 4, collect ad revenue while commenters argue. The Goad Foundation exists because Stage 4 became an industry. Their rules are the adult response. Show us 20 grams, 1 minute, 10 centimeters, no cheats, reproducible on our bench. The silence of that prize is data, not proof that clever people stopped trying, proof that every cheat we know how to name still fails when strangers measure it. Some people bring up dark energy here. The mysterious stuff pushing cosmic expansion faster over large scales. Dark energy is about the geometry and energy budget of the universe as a whole. It is not a gadget you install under a skateboard. It does not help Marty McFly in Hill Valley. We are looking for something local, an object that stops responding to Earth's pull the way ordinary matter does. Dark energy belongs in cosmology lectures. Hoverboards belong in propulsion physics fantasies. Keep them separate or the words stop meaning anything. Dark energy matters to this video only as a cautionary cousin. Observations of distant supernovae and the cosmic microwave background suggest about 70% of the universe's energy budget today acts like a repulsive component in Einstein's field equations on cosmological scales, accelerating expansion instead of slowing it. That is not a lab trick you can shrink onto escape. It is an averaged effect across billions of light years involving fields and densities we barely understand. Conflating dark energy with anti-gravity is how pop science creates false hope. One is a universe-scale inference from telescopes. The other would be a device-scale violation of how local mass couples to spacetime. To space, same word gravity in both sentences. Completely different problems. With the definition locked, the honest question becomes brutal. Has anyone ever found a way to nullify gravity? Not balance it, nullify it. The short answer from mainstream physics is no. And the long answer is why this video exists. Because the long answer walks through the best attempts, the best prizes, the best experiments, and the best reasons the universe seems to refuse the idea. The long answer has a spine. Start with a movie hoverboard. Strip away magnets, air, and rails until only true anti-gravity remains. Show why levitation demos win. Because electromagnetism crushes gravity in any fair fight. Follow the money. NASA BP, good euros. To see who paid for nullification attempts and got null results. Rebuild gravity from Newton to Einstein so you understand what would have to change for anti-gravity to be real. Test the headline fixes. Wushu, negative effective mass, CERN anti-hydrogen, and watch each one fail the hoverboard test while succeeding as real science. End where we started. Earth still pull. The fantasy was never stupid. The accounting was always strict. Humanity's appetite for anti-gravity is not new, and it is not silly. It is expensive. In 1996, NASA stood up the Breakthrough Propulsion Physics program, managed by Mark Millis at what was then Lewis Research Center. The program ran through 2002 and spent about $1.2 million over its lifetime. Modest by aerospace standards, but serious as a signal that even institutional spaceflight wanted an exit from rockets. BP was not only anti-gravity. It surveyed warp drives, wormholes, vacuum energy, superluminal quantum effects, and propellantless propulsion in general. Anti-gravity sat on the list alongside ideas that sound like Star Trek pitched by people with PhDs. Millis and colleagues published workshop reports through the late 90s documenting what might be worth testing near-term versus what belonged in the far speculative bucket. When the program ended, summaries classified several anti-gravity avenues as non-viable, including gyroscopic anti-gravity claims and certain electromagnetic coil arrangements that had made the conference circuit. That does not mean NASA proved anti-gravity impossible forever. It means funded scrutiny found no reproducible effect that looked like gravity switching off. The BP story matters because it shows how a serious agency separates curiosity from propulsion. NASA did not build a classified anti-gravity hangar. It funded peer-reviewed probes of fringe claims with explicit milestones, determine whether foundations exist, identify affordable experiments, select tasks, publish null results. Mark Millis documented management methods designed to keep visionary goals from swallowing credibility. Some topics landed in the keep researching bucket. Others, including gyroscopic weight reduction and Hooper anti-gravity coils, landed in non-viable. That finding system is less glamorous than a conspiracy thread, but it is how you avoid wasting launch budgets on magnets that only work when the experimenter stands on the scale wrong. Millis later founded the TOR Zero Foundation to continue visionary propulsion outreach after NASA reorganized advanced transportation research in 2002. The public narrative sometimes treats that reorganization as proof someone found anti-gravity and hid it. The published record points elsewhere. Speculative research below technology readiness level 3 was deprioritized while near-term propulsion continued. Null results are boring until you need them to avoid repeating hoaxes. BP's legacy is a shelf of honest maybes and honest no's. Both are valuable when the internet only sells maybes. And Pachinal, private money, made the same bet with sharper teeth. Since 2004, the Goad Foundation in Germany has offered the Goad Award for gravitational research. €1 million to whoever can make an object weighing at least 20 grams float at least 10 centimeters above a support for at least 1 minute, using only a direct influence on gravity. Magnetic levitation is explicitly banned. Buoyancy is banned. Aerodynamic tricks are banned. The Foundation must be able to reproduce the effect. The prize has been open for years. Nobody has collected it. The Foundation's own replication attempts on historical claims, devices that look like anti-gravity in YouTube thumbnails, failed to find anything that survived controlled measurement. That pattern matters. It is not one lab being conservative. It is prize money sitting on the table while inventors keep submitting ideas that break when someone else holds the stopwatch. The GERD rules read like a lawyer wrote them because every cheat has already been tried. If your device secretly blows air, it is disqualified. If it hides electromagnets, disqualified. If it heats gas to change density, disqualified. The Foundation wants reproducible nullification of weight in front of their instruments, not a performance for a camera. Dr. Rhys Powey, with power was sparse. Michael Goad established the institute in 1998 specifically to test gravity anomalies with strict protocols. Decades of submissions later, the €1 million remain unclaimed, not because the Foundation refuses to pay, but because no entry survives independent replication under the published terms. Why does the dream persist anyway? Because the applications are obvious. Transport without friction against roads or rails. Logistics without the fuel cost of lifting mass against Earth's pull. Military strategists during the Cold War fantasized about lifting tanks or changing the balance of forces in ways that sound like science fiction until you read declassified curiosity files. Science fiction goes further. Stable wormholes, if they exist, need exotic matter with negative energy density. Ideas that get tangled with anti-gravity language even when the physics is not the same. The hoverboard is a joke you can hold in your hand. The strategic and cosmological versions are why governments and foundations fund weird propulsion studies in the first place. Miguel Alcubierre's warp drive metric from 1994 is a famous example of how anti-gravity language bleeds into serious relativity. The math describes a bubble where space-time expands and contracts around a ship, theoretically allowing faster than light travel without the ship locally breaking light speed. But constructing such a bubble requires negative energy density at scales nature does not hand us casually. NASA BP funded related conceptual work because checking the math is cheap compared with missing a real propulsion revolution. The program did not produce a warp engine, it produced boundaries. What physics allows on paper versus what engineering can source in material fields. Wormholes sit in the same drawer. You can write Einstein-Rosen bridges in equations. Holding them open requires conditions we have never seen in a lab. Anti-gravity and warp drives share the same emotional address, escape from distance and weight, but they are not the same technology waiting in a hangar. During the Cold War, both superpowers treated breakthrough propulsion as a strategic fantasy, worth cataloging even when budgets were secret. Rockets work. But rockets are expensive, loud, and limited by the rocket equation. A platform that could hover without exhaust would rewrite reconnaissance, logistics, and space access. Documents from later propulsion workshops show how seriously engineers treated the search for physics beyond chemical rockets, not because anti-gravity was confirmed, but because ignoring a potential revolution is also a policy choice. Most avenues dead-ended. BP's published summaries are part of that archive. Here is what we checked. Here is what failed replication. Here is what still needs better instruments. Transparency is boring compared with conspiracy, but it is how you stop funding the same hoax twice. To understand why anti-gravity refuses to appear, you have to understand what gravity is, and that story has two famous chapters. Newton first, Einstein second. Isaac Newton gave us the law of universal gravitation. The force between two masses is proportional to the product of those masses and inversely proportional to the square of the distance between them. In symbols, F equals G times m1 times m2 divided by r squared. G is the gravitational constant, tiny in human units, which is another way of saying gravity couples weakly. Masses always attract. There is no minus sign hiding in the formula. That flips attraction to repulsion the way opposite electric charges behave. Newton published that law in the 17th century, and it still predicts planetary orbits, cannonball arcs, and satellite paths well enough for most engineering. NASA sent people to the moon with Newton before anyone needed Einstein on the dashboard. That success is part of why anti-gravity dreams keep returning to Newton's algebra. If charge can be positive or negative, why not mass? The symmetry is seductive on paper. Two positive masses attract. Two negative masses would repel in the naive extension. A positive and negative pair might hover in balance like electric dipoles. You could imagine binding matter and antimatter like negative mass partners into floating platforms. The math writes itself in a freshman notebook, and here Newton's story collides with a seductive analogy. Coulomb's law for electric charges looks almost identical. Force equals K times Q1 times Q2 divided by R squared. But electric charges come in positive and negative. Like charges repel, opposite charges attract. So the natural question, the one that has launched 1,000 garage experiments, is whether mass might also come in two flavors. Positive mass and negative mass. Put two negative masses together, and maybe they repel. Bind a positive and a negative mass, and maybe they hover. Mass would behave like charge. Anti-gravity would fall out of the algebra. History tried that analogy in public. 19th century physicists already knew gravity and electrostatics looked like siblings in the math. 20th century science fiction ran with negative mass as a plot device. 21st century YouTube reinvented the same hope with new magnets and new branding. The analogy survives because it is beautiful. It fails as engineering because mass is not charge. Charge comes in plus and minus buckets that cancel in neutral objects. Mass in the standard model accumulates always toward attraction on planetary scales. Finding negative gravitational mass would not extend Newton. It would break the structure Einstein verified in eclipse observations. and that LIGO later saw in gravitational waves from merging black holes, ripples in geometry itself, not secrets you can cancel with a coil. That hope survives until you look closely at what mass means in physics. In everyday language, we treat mass as one thing. In deeper mechanics, there are two roles. Gravitational mass is the mass that creates and responds to gravity, the m in Newton's law and the source of curvature in Einstein's theory. Inertial mass is the mass that resists acceleration. The m in F equals ma. You feel inertial mass when you push a car. You measure gravitational mass when you step on a scale. Newton and Einstein both assume these two masses are identical for ordinary matter. That identity is the equivalence principle, tested endlessly with pendulums, satellites, and precision instruments. Anti-gravity in the strict sense needs gravitational mass to misbehave, to be negative or zero for some object. Pushing on inertial mass alone is not enough if the object still falls when you let go. The equivalence principle is not abstract philosophy. The microscope satellite mission from Keynes and ESA compared the free fall of different materials in orbit and found no difference within about 1 part in 10 to the 14, mind-bending precision. Lunar laser ranging measures the moon's orbit and constrains how gravity might treat different compositions. Every test that passes tightens the screws on theories that want mass to respond differently to gravity depending on hidden label. If you claim anti-gravity, you are claiming to break or extend one of the most tested symmetries in physics. That is allowed in science if you bring extraordinary evidence. So far, the evidence keeps saying mass falls the way mass always fell. Einstein's general relativity reframes gravity again. Gravity is not a force transmitted mysteriously across space like a phone call. It is geometry. Mass and energy tell space-time how to curve. Curved space-time tells matter how to move. Planets orbit because local spacetime is shaped into paths that look like ellipses when you project them onto diagram. Light bends around the sun because light follows the straightest possible route through curved geometry, straightest in the sense physicists mean, which is not the same as a straight line on a flat page. You can feel the difference in a thought experiment Einstein loved. Stand in a closed elevator on Earth and you feel heavy. Accelerate the same elevator in deep space at 9.8 meters per second. Squared, and you feel identical heaviness. Without windows, you cannot tell gravity from acceleration. That equivalence is not a party trick. It is the seed of general relativity. Gravity and accelerated frames are linked. Now ask what anti-gravity would mean in an elevator that truly cancelled Earth's field. Objects would float, not because the cable broke, but because the geometry locally removed the need for a floor push. No demo on YouTube achieves that. At best, they reduce the normal force by pushing up with another interaction. Einstein published General Relativity in 1915. Eddington's 1919 eclipse expedition measured starlight bending near the sun and made Einstein famous because prediction beat mystery. Gravitational lensing today lets astronomers map dark matter by watching distant galaxies distort through intervening mass. Gravitational time dilation keeps GPS honest. Each success reinforced one idea: gravity is geometry we can measure with exquisite tools. Anti-gravity asks to delete geometry locally without deleting mass. That is a much rarer claim than building a better magnet. The century of confirmations behind Einstein is why negative mass and anti-gravity devices face skepticism that is not laziness. It is Bayesian updating with a lot of data. In that picture, you can ask a mathematically clean question. What if mass entered Einstein's equations with a negative sign? Formal solutions with negative mass exist on paper. They curve spacetime the opposite way from ordinary mass. Two positive masses attract. Negative mass in those toy models can produce repulsive-looking trajectories, the kind of behavior anti-gravity hunters want. So why do physicists roll their eyes when someone claims to have built it in a shed? General relativity also gave us tools we use every day without anti-gravity. GPS satellites orbit Earth with clocks that tick faster in weaker gravity than clocks on the ground. If engineers ignored relativistic time dilation, your navigation would drift kilometers per day. That is, gravity as geometry doing something useful, not cancelling the field, but calculating with it precisely. Anti-gravity would be the opposite engineering dream, not measuring curvature better, but deleting curvature locally for a payload. The gap between those two sentences is the gap between modern physics and Hollywood. Because negative gravitational mass opens doors physics has spent centuries trying to keep closed, runaway solutions appear where energy is not bounded from below. Accelerating pairs of positive and negative mass can extract kinetic energy forever in idealized setups, which trashes conservation arguments carefully tested in every lab on Earth. Wormholes and closed time-like curves. Science fiction's favorite time machines often require exotic matter conditions closely related to negative energy density. The universe we observe shows no stable pools of such matter lying around for engineers to mine. When theorists say negative gravitational mass is excluded, they mean it fails the consistency tests that separate interesting equation on a blackboard from stuff you could pick up without the universe exploding logically. Picture two particles, one with positive mass and one with negative mass, placed near each other. In the naive model, both accelerate in the same direction. The positive mass chases the negative mass, while the negative mass runs away from the positive mass. Momentum seems conserved while kinetic energy rises without limit. That is not a hoverboard. That is a perpetual motion machine wearing calculus. Real physics rejects or tightly constrains such behavior, because we do not observe unlimited free energy sitting in paired masses at room temperature. Science fiction uses negative mass for warp bubbles and wormhole braces. Peer-reviewed cosmology uses it as a formal tool with strict conditions, not as a warehouse item. That is the wall anti-gravity keeps hitting, not that nobody wants it, not that nobody funds searches. The wall is that gravity is not an optional setting on matter. The way charge is on an electron. It is tied to how much stuff curves the world. Flipping the sign breaks more than gravity. It breaks the bookkeeping. Every few years, headlines revive hope anyway. In 2017, researchers at Washington State University, led by Peter Engels and Michael Forbes, published results in Physical Review Letters on what they called negative mass hydrodynamics in a rubidium bose, Einstein condensate. They cooled rubidium atoms to near absolute zero until the cloud behaved as a single quantum wave, a superfluid where atoms move in lockstep. Then they applied lasers with spin-orbit coupling, engineering how the cloud responds when pushed. When atoms were kicked out of the trap fast enough, part of the cloud accelerated backward relative to the push, as if it had negative mass. Walk through the experiment slowly, because this is where headlines betray the lab. Rubidium-87 atoms get laser-cooled until they occupy the lowest quantum state allowed by Pauli exclusion in a trap. At nanokelvin temperatures, the cloud becomes a Bose, Einstein condensate, millions of atoms sharing one macroscopic wave function, flowing without viscosity like a ghost fluid. Engels' team then turned on counter-propagating lasers that couple the internal spin of atoms to their motion, creating spin-orbit coupling. That coupling reshapes the energy-momentum relation of the cloud. In certain regions of that relation, an excitation behaves as if its effective mass were negative. Push it one way and part of the wave packet goes the other. The videos are genuinely strange. You shove the quantum fluid, and a piece of it runs toward you instead of away. Forbes described it like the rubidium hitting an invisible wall. BBC and university press offices ran headlines about negative mass created in a lab. Social media did what social media does and skipped straight to hoverboards. Here is where precision matters, and where this video earns its keep against the hype. The WuSu team did not discover a chunk of matter with negative gravitational mass you could weigh on a scale and drop from a balcony. They engineered an effective negative mass in a collective quantum system, a property of how the condensate's waves interfere and respond at certain momenta in the dispersion relation. The electrons and nuclei inside still have positive inertial mass. Put that cloud on ordinary balance in Earth's field, and it still falls down like any other mass. What reversed was the response of a particular excitation under careful laser conditions, not the gravitational coupling of rubidium atoms to Earth. That distinction is not pedantry. It is the entire anti-gravity debate compressed into one experiment. Inertial behavior can look exotic in quantum fluid. Gravitational behavior is what a prize committee cares about when it asks for 20 grams floating 10 centimeters above a table with no magnet. WuSu did not win the Gerd Award. NASA BP would not have classified the condensate as propulsion. The result is still important. It explores how effective mass can flip sign in engineered quantum systems, with connections to solitons, shock waves, and analog models of curved spacetime in condensed matter. But it is not the anti-gravity of Back to the Future. Treating it as such is how good science becomes bad clickbait. Kamichi, Forbes, Engels, and colleagues published in Physical Review Letters, Volume 118, Article 155-301, with simulations matching shock-like behavior and self-trapping in the cloud. Follow-up work worldwide now treats spin-orbit coupled condensates as a playground for negative effective mass hydrodynamics. None of that follow-up claims hoverboards. The community uses the effect to study wave dynamics. Popular media uses it to harvest clicks. You now know which sentence to trust. The Wu Xiu story also revives the two-mass conversation in a useful way. Worry when pop articles say negative mass, they rarely specify which mass. Inertial mass appears in Newton's second law. Gravitational mass appears in the law of gravitation and in Einstein's source term for curvature. The equivalence principle says they are the same for normal matter to exquisite precision. Anti-gravity requires violating or extending that sameness in Earth's field, not merely seeing weird acceleration in a laser trap where gravity is the boring background force. Everyone ignored because the experiment was about quantum hydrodynamics, not free fall. Condensed matter physicists sometimes build analogs of curved spacetime in table. Top systems, optical lattices, Bose-Einstein condensates, fluid flows, because the math of waves on a background resembles the math of fields on curved geometry. That research is fascinating, and it is not anti-gravity hardware. It is a laboratory mirror for testing ideas. Forbes and Engels were clear in their paper that they engineered dispersion, not gravitational coupling. The condensate still sat in Earth's field the whole time, held in place by lasers and magnetic traps that themselves fought gravity with support forces from the apparatus. If you forget the apparatus, you forget the accounting. If negative mass is the forbidden fruit, antimatter is the obvious place the public looks next. The prefix anti sounds like anti-gravity waiting to happen. Antimatter is real. Anti-hydrogen, an anti-proton with a positron orbiting it, has been synthesized and trapped at CERN's antimatter factory. Antiparticles have opposite charge, but as far as every precision measurement has shown, positive inertial mass equal to their matter partners. The equivalence principle predicts they should fall in Earth's gravitational field, the same way hydrogen does. But physics is experimental. You still have to drop the stuff and watch. Antimatter is not science fiction fuel for starships yet. It is a mirror of ordinary matter at the particle level. Antiprotons, positrons, antihydrogen, produced in tiny amounts in accelerators, stored in magnetic traps because contact with normal matter annihilates both in a flash of gamma rays. The alpha collaboration at CERN cools and stacks anti-atoms one careful step at a time. The public question is almost childlike. Does antimatter fall up? The scientific question is sharper. Does antimatter have the same gravitational mass as matter? Or does the prefix anti secretly flip gravitational coupling? General relativity says no flip. Experiment must still check, because history punishes assumption that drop is harder than it sounds. Antimatter annihilates the moment it touches ordinary matter. You cannot simply release a ball of anti-hydrogen over a balcony and film it with a phone. The Alpha collaboration built magnetic bottles that hold anti-hydrogen in vacuum, then designed Alpha G, a vertical trap, to release atoms slowly and infer which direction gravity pulls them by where they annihilate on the chamber walls. In September 2023, Alpha published results in Nature. Anti-hydrogen falls downward, not up, down. Within experimental uncertainty of about 20% of Earth's gravitational acceleration. The behavior matches ordinary matter falling in a gravitational field. Einstein's general relativity passed another adversarial test, the anti-gravity of science fiction, where antimatter floats away like a balloon with opposite charge, did not show up. The Alpha G apparatus is a lesson in patience. Anti-hydrogen must be synthesized particle by particle, trapped in a vacuum chamber at CERN's antimatter factory, cooled and held in a magnetic minimum that acts like a bowl for neutral anti-atoms. When researchers slowly reduce the trap depth, anti-atoms escape upward or downward and annihilate against the walls of the detector, producing particle tracks the team reconstructs. Gravity biases the escape fraction. Matter simulations predicted roughly 80% exiting downward versus 20% upward for hydrogen in the same trap geometry. Alpha averaged trials and found anti-hydrogen followed the same bias. No upward fountain, no anti-gravity hover. Earlier experiments had placed upper limits on antimatter gravity, but Alpha G was the first direct measurement campaign purpose built for the question. The collaboration notes precision will improve. A follow-up atomic fountain with anti-hydrogen could push accuracy toward 1%. Even then, the expectation in mainstream physics is confirmation. not reversal. General relativity predicts matter and antimatter fall the same in a gravitational field. So far, experiment agrees. That result closes a door many people hoped would open. If antimatter had fallen upward, it would have been the discovery of the century and a genuine revolution in gravitational physics. Did not. But this dreamed anti-hydrogen falls. The dream of anti-gravity via antimatter becomes another engineering, not magic lesson. Antimatter still matters enormously for fundamental physics, medical imaging, and understanding symmetry in the universe. It just does not cancel gravity. Future experiments will tighten the error bars. Alpha G reported results consistent with downward fall, with uncertainty around 20% of G, good enough to rule out wild reversal, not yet the part per million precision physicists want for a final word. Other collaborations propose dropping anti-hydrogen in taller vacuum towers or using interferometry. Each generation of experiments costs years because antimatter is scarce and delicate. The answer so far supports Einstein. Antimatter is not a loophole labeled anti-gravity in the brochure. It is matter with opposite quantum numbers, subject to the same space-time geometry as everything else we have dropped since Galileo. Where does that leave us with gyroscopes, conspiracy uploads, and the next viral device? Gyroscopes precess. They resist reorientation in ways that feel like magic when you hold a spinning wheel. For decades, hobbyists and a few researchers wondered whether spinning mass could partially cancel weight. Careful analysis and programs like NASA BP found no reproducible weight loss that survived blinded measurement. What you sometimes measure is torque, vibration, sensor error, or the experimenter leaning without noticing. The feeling of lightness is real in your hands. The change in gravitational mass is not. A gyroscope resists being tipped because angular momentum wants to keep pointing the same direction in space unless a torque acts. Push on the axis and the wheel precesses sideways instead of obediently tilting where you pushed. That is conservation of angular momentum, not a dial turned down on Earth's field. Put the gyro on a scale while you spin it, and the reading does not permanently drop because gravity stopped caring. At most, you measure transient forces from handling, vibration, or the scale's own quirks. NASA BP listed gyroscopic anti-gravity among non-viable approaches after reviewing claims that failed replication. The internet keeps rediscovering the same demo anyway, because spinning wheels feel like they cheat physics when you are holding them. So anti-gravity, in the strict nullify gravity sense, remains where it has been for decades. A prize nobody wins, a propulsion program that archived its folders, a movie effect still waiting for physics that may never arrive. That is not the same as saying gravity is boring. Gravity is the reason black holes exist. Regions where curvature is so extreme that light cannot climb out. Gravity is the reason planets orbit, tides rise, and GPE satellites need relativistic corrections to keep your map from drifting. Gravity gives us Lagrange points where spacecraft can sit almost without fuel, surfing balanced fields between Earth and the Moon or the Sun and a planet. We did not need anti-gravity to get wonders. We needed to stop pretending the wonders we have are the same as switching off the field. Lagrange points deserve a sentence because they trick the intuition the same way maglev does. At L1, L2, and the other equilibrium points in the Earth, Sun, or Earth-Moon system, a spacecraft can stay roughly fixed relative to two massive bodies because gravity and orbital motion balance in a rotating frame. Mission planners use them for telescopes like James Webb and for station keeping with modest fuel burn. It feels like hovering in space. It is still gravity doing the accounting. You are in a carefully chosen orbit, not in a zone where Earth's field was cancelled. Confusing balance with nullification is how anti-gravity myths keep reproducing on social media. James Webb sits near the Sun Earth, L2 point, 1 million miles from Earth, orbiting in a complicated halo path that keeps it cold and stable for infrared astronomy. The telescope is not anti-gravity. It is exquisite ballistics. Engineers used gravity assists, fuel burns, and Lagrange geometry because cancelling mass coupling was never on the menu. Every deep space mission is a reminder that we navigate the field we have, not the field we wish we could switch off. Black holes are the opposite fantasy. Gravity, So strong nothing we know escaped. General Relativity predicted them before we had pictures. Event Horizon Telescope collaborations later imaged the shadow of M87's black hole and Sagittarius, a star at the Milky Way's center. No anti-gravity device gets you out once you cross the horizon. The mystery of gravity is not that it is weak on tables and strong in collapsed stars. The mystery is why the weakest force at the atomic scale dominates the largest structures in the cosmos, without ever offering us an off switch at human scale. Tides are another everyday reminder that gravity is geometry in action. The moon pulls more strongly on the near side of Earth than the far side. The oceans bulge. Nothing cancelled Earth's field for the water. Differential gravity across a body produced a pattern we can predict centuries ahead. Surfing is riding the side effects of a force too weak to lift a spoon, yet strong enough to move seas. Anti-gravity would not improve surfing. It would rewrite what weight means for every molecule in the ocean. Science fiction keeps anti-gravity alive because stories need freedom from friction. Star Wars, Star Trek, Back to the Future all assume propulsion or levitation without paying the rocket equation every scene. Physics keeps answering that the universe charges interest on math. The interest rate is G. You can pay with magnets, with rockets, with wings, with quantum tricks that reverse effective inertia in a trap. You cannot yet unsubscribe. Maybe that is the adult version of the hoverboard question. We wanted a technology that edits Earth's pull locally. What we built instead are maglevs that fight the weakest force with the second strongest. Rockets that spend most of their fuel lifting fuel, and quantum labs where effective mass can flip sign inside a trap while the table still presses up on the apparatus. Progress is real. Anti-gravity, as Hollywood defines, it is not here. There is also a humility lesson hiding in the numbers. Gravity is the weakest force, yet it shapes the cosmos because it accumulates and because, as far as we know, it only attracts in the environments we inhabit. Electromagnetism builds chemistry and light. The strong force builds nuclei. The weak force governs certain decays. Gravity builds solar systems, galaxies, and black holes from the same mass you measure on a bathroom scale. Physicists call the mismatch between gravity's weakness at quantum scales and its dominance in cosmology the hierarchy problem, one of the deepest open wounds in fundamental physics. Anti-gravity would not solve that problem. It would be a technology built on solving it first. You do not need anti-gravity to feel wonder about gravity. Drop a hammer and a feather on the moon, and they fall together because there is no air, and because gravitational acceleration in the same field does not depend on mass. Another face of the equivalence principle Apollo astronauts demonstrated on camera. Watch LIGO announce gravitational waves, and you are hearing space-time ring like a bell when black holes merge. None of that required canceling the field. It required listening better. Maybe the mature response to the hoverboard meme is not cynicism but redirection. We wanted one gadget to delete weight. The universe offered us geometry, waves, and precision clocks instead. That is not a consolation prize. That is the actual plot of 20th century physics. If someone does find it tomorrow, reproducible 20 grams for 60 seconds 10 centimeters up, no magnets, no fans, no hidden wires. Until then, the honest story is simpler. We was procreated den, they probably to our. And fath how we, do coke. We interested define your terms. Separate balance from nullification. Respect the difference between inertial tricks and gravitational mass. Watch antimatter fall down. Read the NASA summaries. Enjoy the movie. And when you see a floating train, remember, Earth is still pulling. We just got good at pushing back. Gravity was probably the first force you noticed as a child, and the last force you understood as an adult, if understanding ever arrived. It holds you to the planet, moves the tides, binds galaxies, and hides black holes at the centers of many of them. Anti-gravity would have been the cheat code, the ability to opt out. The universe instead gave us weaker forces that are easier to weaponize against weight in controlled setups, and a theory of curved spacetime that keeps passing tests we did not design to be easy. That is not a defeat. That is the map. And maps, even without hoverboards, are how you actually move. Thank you very much, and see you next time.